If you're writing these notes by hand, this is going to be your title, 3.2 Notes and Skills, Identifying Intercepts is the title of what we're doing today. So go ahead and write that at the top of your page if you're writing notes by hand. We're going to start off by reviewing some vocab. This is vocab we've actually already talked about. So you can go ahead and work on copying that down. However, we already do have these definitions recorded. I'm going to draw a little diagram over this on the side. That's the main thing that I want you to have down. We're going to kind of talk about this in terms of a picture. So if you want to have that vocab written down, this is what we're talking about. An intercept, remember, is a point where the graph crosses an axis. You can simplify that definition a little bit, but that's the main idea. It's where a point where the graph crosses the axis. And we have two axes, axi, x and y. So we have two types of intercepts. We have a y-intercept, which is where the graph crosses the y-axis, and we have an x-intercept, which is where the graph crosses the x-axis. So like I said, you can copy those definitions down if you'd like to. We actually already did them a couple weeks ago. The most important thing I want you to get down, though, is this little picture I'm going to draw, because this is going to really help show what's going on. So we have a coordinate plane kind of here, and we've been talking a lot about lines. So if I have a line is going to cross each axis one time. So where it crosses the x-axis, this is called the x-intercept. Where the graph crosses the y-axis, this is called the y-intercept. Now, we've been talking a lot about the y-intercept because we have to use the y-intercept to write the equation of a line in slope-intercept form, y equals mx plus b. The y-intercept has a special letter, b, that's associated with it. So if we're talking about the value of b, we're referring to the y-intercept. However, the x-intercept also has a special name. Sometimes the x-intercept is referred to as the zero. So we sometimes call that the zero. So if you're being asked, and that's also up here, if you were asked to find the zero, all it's asking for is the x-intercept value. One more important idea that I want to point out that we've kind of already discussed, but I want to just make it very clear, is that the x-intercept happens at the point x, 0. The y value of the x-intercept is 0 because there's no vertical change. It's the point x, 0. And that's a really important idea that's going to help us solve as we go on today. Similarly, the y-intercept is at the point 0, y. The x value is 0. So we want to point out that when we have an x-intercept, the y value is 0. And when we have a y-intercept, the x value is 0. So like I said, all these words over here in definitions, you can write those down if you'd like to, but the most important points I just covered in this little diagram. So make sure you have that diagram written down, whether you're handwriting your notes or whether you printed the notes. Make sure that you have all of that written out. So we're going to use that to jump into some examples. So we're going to be identifying intercepts given different information. So if you're writing notes by hand, this section of your notes is going to be given a graph. We're going to identify the intercepts given a graph. So write that title down for this section. And this is going to be pretty straightforward when we're given a graph. We've actually already practiced doing this, so it's a bit of review. The first thing that I'm asked to find, and we've got 3 examples here. You can label 1, 2, 3. If you're drawing this graph by hand, this is what I want you to do. Draw yourself a little y-axis and an x-axis, and notice that you're crossing at 5 and you're crossing at 3, and then just connect those dots. So to identify our x-intercept, the x-intercept is where the graph crosses the x-axis. Where does this graph cross the x-axis? Okay, 3 is the x value, 3, 0 would be the point. Very good. So our x-intercept is 3, 0. We're going to express it as a point. Right? Then we're finding the y-intercept. We should be pretty comfortable with this. I look at my y-axis. Where does this graph cross the y-axis? We cross at 0, 5. That is the y-intercept. And that's it. Given a graph, that's how you do it. So you just look at the graph and you write down those points where it's crossing each axis. So you'll be responsible for completing 2 and 3 on your own as part of your assignment for today. So I'm going to be moving on, but you'll be responsible for completing 2 and 3 for your submission for today. Our level of confidence on that should probably be around a 4 or 5. So I'm guessing you're feeling pretty good about, if you're given a graph, finding those intercepts. So now we're going to move on. We're going to look at a different situation. This time we're going to be given a table. So if you're writing notes by hand, you're going to write given a table. And again, we have a couple examples here. If we're given a table, we're going to use the idea that intercepts happen at zeros, okay? So our y-intercept happens when x is 0, and our x-intercept happens when y is 0. So if I'm given a table of values, what I'm going to look for are zeros. So first, I'm asked to identify my x-intercept. So my x-intercept is going to happen when y equals 0. So do we see a point on here where y has a value of 0? If so, what is it? What is our x-intercept based on this table of values? We have a y value of 0 when x equals 1. So this point, we can visualize that in our head. The point 1, 0 means I'm going over 1, and I'm not going up or down at all. So if I'm just going over 1, then that is where my graph crosses the x-axis. That's the x-intercept. And so I'm going to express that as the point 1, 0. Similarly, I'm going to identify my y-intercept. A y-intercept happens when x equals 0. What is our y-intercept based on this table? Yep, if I visualize the point 0, 2 in my mind, I'm at 0 and I go up 2, that is on the y-axis. So the point 0, 2 is my y-intercept. Again, I think that's probably, you're probably at a level 4 or 5 confidence. Given a table, it's pretty straightforward. You're going to be doing number 2 on your own for practice for today. So we're going to skip that one for now. But probably at this point, you're feeling pretty confident about intercepts, and that's awesome. This next section we're going to move into is probably going to push you a little bit. Next, we need to be able to find intercepts given an equation. So if you're handwriting your notes, that's going to be your next section. All right, we've already practiced finding y-intercepts given an equation, right? We put our equation in slope-intercept form, and we could identify that b value, that's our y-intercept. You can still do that to find your y-intercept. You could still put this in slope-intercept form, find whatever b is, that is your y-intercept. But you can't use slope-intercept form to find your x-intercept. There's no x-intercept value in slope-intercept form, only a y-intercept. So today I'm going to show you an alternative way to find both the x-intercept and the y-intercept. The strategy we're going to use rests on this idea that I've been trying to reinforce, that an x-intercept happens when y equals 0, and a y-intercept happens when x equals 0. That is going to be the idea that's going to help us find algebraically our x and y intercepts. So when we're given this equation, we have no graph, we have no table. We only have our algebra skills. Now you could put this in slope-intercept form, graph it, and then look at it on a graph. So that's always a strategy you can do if you forget. But algebraically, there is a way we can find each intercept. So if I'm looking for the x-intercept, an x-intercept happens when my y value is 0. So this is what I'm going to do. My x-intercept is going to be the point x, 0. So what I'm going to do is I'm going to plug in 0 for y, and I'm going to solve and see what I get for x. Whatever value I get for x, when I let y equal 0, it's going to be my x-intercept. So that's the strategy we're going to use. So I'm going to use the point x, 0. I'm going to plug that into the equation that's given to me, and I'm going to solve algebraically for x. So this is what it looks like. Copy this equation down. 3, what am I plugging in for x? I'm just plugging in x for x. So 3x plus 2 times, instead of y, I'm plugging in 0. So 2 times 0 equals 6. The only variable that I have is x, so I should be able to solve for x using algebra. So first I simplify anything I can. 2 times 0 is just 0. Everything else is going to drop down. Well, 3x plus 0 is 3x plus nothing, so I really have 3x equals 6. In order to get this x by itself, I'm going to divide both sides by 3, and I'm left with x equals 6 over 3, which is 2. So when I plugged in 0 for y, I found out that when y equals 0, x equals 2. So that is my x-intercept. My x-intercept is the point 2, 0. I can then put that point on my graph over here. 2, 0 is right here. That's my x-intercept value. So here's my question. If I can plug in 0 for y to find my x-intercept, how do you think we could find our y-intercept? Yeah, we're going to plug in 0 for x. Very good. So I'm going to use this idea that my y-intercept happens when x equals 0. So if I want to solve for y, I'm going to plug in 0 for x. Into the same equation, 3. Now instead of putting an x, I'm going to put a 0 plus 2. This time I'm going to leave y. I'm going to let y be y so I can solve for it, equals 6. So now I have a single variable y that I'm solving for. Well, 3 times 0 is just 0, plus 2y equals 6. 0 plus 2y is 2y plus nothing, so I just have 2y equals 6. In order to get this y all by itself, I'm going to divide both sides by 2. These 2's cancel, leaving me with y equals 3. So when x is 0, I get a y value of 3. That means that my y-intercept is the point 0, 3. I can plot that point on my graph. 1, 2, 3. And if I connect these dots, I have my line. You'll be responsible for trying number 2 on your own as part of your assignment for today. Finally, our goal here is to identify intercepts given a situation. So this will be your last one. And if you're handwriting this first example, I just want you to write down this key information. You don't necessarily have to copy down all of this. So it says a bus is driving at 60 miles per hour toward a bus station that is 250 miles away. So that's the key information that I want you to write down if you're writing this by hand. 60 miles per hour, 250 miles away. That's how far that it has to go. You could also draw a little picture to help identify what's going on here. If we're driving along a route, this is our destination. This is where our bus is. This is my great picture of a bus. And this distance is 250 miles. That's how far the bus needs to go. Even if you're on a printed copy, you could draw that little image to put that in your mind. So first, I'm being asked to write an equation to represent the distance, D, my distance is D, from the bus station that the bus is T hours. So I've got distance and time, hours, after it has started driving. So I'm just going to ask you to try and follow along with my thinking here. This is a slightly, we've done a little bit with writing linear equations given a situation, but I understand this might be pushing your limit a little bit. So just kind of follow along and try and understand my thought process as I think through this. So my distance D, it wants me to set up an equation to solve for D. So my distance D is equal to, well, at first, my distance is 250. That number is given to me. And what's happening is this bus is going towards the final destination. As this bus moves towards the destination, my distance is shortening. The bus is getting closer and closer and closer. So that 250 miles that's my initial distance that I have to travel, as the bus moves, that distance is getting smaller and smaller. But I want to say that my initial distance, at first, I've got to go 250 miles. The distance equals 250 miles. So at the starting point, D equals 250. But it wants me to write an equation that shows the distance as time is passing. So as time is passing, that distance is getting smaller and smaller. Mathematically, the way that I represent that something is getting smaller and smaller is by subtracting it. So that distance of 250 is getting smaller. And I need to ask, how is it changing? How is it getting smaller? Well, the bus is driving 60 miles per hour. That means every hour, which is T, after every hour, it's 60 miles closer. So I'm starting at 250 and I can subtract 60 for every hour, which is T. So this is my equation. I'm going to talk through like an example of plugging in just to, as you write that down, to think about how this would work. If my time is 0, meaning I'm just got into the bus, if I plugged in 0 for T, 60 times 0 is 0, so I'd have 250 minus 0. My distance is 250. That makes sense. At the start, before I start driving, I have 250 miles to go. But after 1 hour, if I plugged in 1 for T, I'd have 250 minus 60 times 1, which is 60. So I would have a distance of 190. That makes sense. After 1 hour, 1t, my distance would be shorter. It would be only 190 miles. If I plugged in 2 for 60, I'd have even less time and less time and less time. So this equation represents my distance from the bus station after I've started driving. So this looks like a linear equation. We've got d and t, but it looks like y equals mx, if I rearrange this, negative 60x plus 250. So this is a linear equation. We're just using different variables. And instead of having mx plus b, we put b minus mx. And I know this might be stretching you a little bit. If you're feeling stretched, that's okay. So this is my equation. The next step is to identify the intercepts. So my x-intercept is where this graph is going to cross the x-axis. So we may want to go ahead and try and graph this. And actually, when I see this in the form y equals mx plus b, it's actually really easy to identify that y-intercept. Because remember, my y-intercept is just this value here. So my y-intercept is actually the point 0, 250. At time 0, my distance is 250. So we could plot that point on the graph. 0, 250 is my starting point. What that means is when I start driving, I have 250 miles to go. So before driving, at time equals 0, there are 250 miles to go. That's my total distance. All right, so then to identify the x-intercept, we can use the same strategy we used before. Remember, the x-intercept happens when y equals 0. So if I let y equal 0, and remember in this context, my x value is t, time. So I'm looking for my time. Where is this going to cross the x-axis? So what I'm going to do here is I'm going to plug in, I'm trying to solve for t, so I'm going to let y equal 0, or my distance equals 0. I'll write that in words. I'm going to let distance equal 0. Because I'm trying to find when my distance is 0, meaning when I have arrived, how long is that going to take? So I'm going to plug that in. If distance equals 0, I'm going to say 0. I'm using this equation right here, if you're confused, right here. 0 equals 250 minus 60t. T is what I'm solving for. I'm trying to find at what time does my distance equal 0. So now that's the hardest part, is getting that set up. Now it's just straight algebra. Trying to get t by itself, so I'm going to subtract 250 from both sides. I get negative 250 equals negative 60t. In order to get that t by itself, I'm going to divide both sides by negative 60. And I'll plug that in my calculator. Over here, that cancels. So I'm left with t equals, and negative 250 divided by 60 is 4.16666. So I'll say 4.16. So my x-intercept is 4.16 comma 0, where this is T and this is D. If I were to graph that, 4.16 is going to be kind of right here. 4.16 comma 0. I can connect these dots to show that as time goes on, I'm getting closer and closer to my destination until at 4.16 hours, I have 0 miles left to go, meaning I've arrived. So that's how we can interpret this for the meaning is it will take 4.16 hours, because that's my time value, to drive the 250 miles. All right, so I understand if you're feeling like even at a 1 or a 2 on that given a situation, that is okay. If you're feeling at like a level 1 or 2, like I kind of barely knew what was going on, I was just kind of copying down what you were doing, that's okay. I do want you for your assignment tonight to attempt number 2. I think that number 2 is a little bit easier to understand. So hopefully you can at least get it figured out a little bit. Just do as much as you can do. Give it a try. This is where real learning happens, is when you try something that feels a little bit difficult. If you need to rewatch this video, this lesson, especially for given an equation and given a situation, that will be available to you. So if you're feeling iffy, like a 1, 2, or 3 level, then I recommend watching that video.